In today's session, we are going to study about different methods of clustering. In the previous session, we have seen what is clustering, what are the types of data we use in clustering, and what is the data structure, what are the properties, everything. Basically, we have seen 4 types of data. Those are your interval variable, binary variable, your categorical variable, and your mixed variable. So now the next is about your methods in the clustering. In methods, totally we have total 6 methods in which we are going to study the 4 methods. First one is your partitioning method, next hierarchical method, next is your density based, then your grid based, then comes with your model based, then your constraint based. Now your model based and constraint based both are not there in your syllabus. According to your syllabus, we are going to study the other 4. Those are your partitioning method, your hierarchical method, density based, and grid based. In today's session, we are going to study about your partitioning method. Now the word itself is telling us, what do you mean by partition? It's a division. So we are, whatever the data items or data sets we have, we are going to divide it into k partitions. Here k is nothing but number of clusters. Partitions is nothing but a cluster. We are going to divide n number of cluster from a group of data items or data sets. As I told you, we are talking about your partitioning method. We will be doing it into k partitions. This k partitions is nothing but you are going to make a represent it in the form of a cluster. This you are going to represent it in a cluster. Now you all have to remember that always k should be less than or equal to n. Now what do you mean by k? K is size of the each individual, n is total number of data items. Whatever the n number of data items you have, this should be always greater than your size of the each individual cluster. For suppose if I have 10 data items, so my cluster should not have completely 10 in it. It should be less than 10. Now you have to remember the 2 rules here which are very important. First one is each partition at least one object should be present in each partition. Now if I am making 2 clusters, in 2 clusters at least one object is nothing but the data item. Your data item is also called as your object. So it should contain at least one object. Next is each object should belong to only one partition. Now if I have number 3 data item in K1 partition, that is in K1 cluster, then it cannot be there in other K2 or K3 clusters. It is there only in the K1 cluster only. Now to solve this partitioning method, we are going to use k-means algorithm. What do you mean by k-means algorithm? K-means algorithm is, here the data is divided into clusters based on your distance and centroid. What are the parameters we are using here? This is divided into clusters based on what your distance and centroid. We are going to calculate distance, we are going to calculate centroid. Now for your distance, we are going to use your ED. What do you mean by ED? ED stands for Euclidean distance. Your ED stands for your Euclidean distance. Now let's see a simple example, and this is your very important question. Now let's see with your basic simple example. I have got height and weight with 5 data items in it. Now initially, for what I have to do, first I have to divide the given into a cluster. I will be dividing it into what? K1 and K2, 2 clusters. Done. Now I am going to check with 2 pairs. Now I am going to write the pairs here. 185, 72 is one pair, 170 and 56 is the other pair. Next 168 and 60 the pair, 179, 68 is one pair, 182 and 72 is my other pair. Now from this I have chosen K1 and K2 as 2 clusters and I have taken the pairs. Now my next point is I need to randomly select the centroids. Now what I have to do? I have to randomly select the centroids from the pairs. So now what am I doing? Out of all the 5 pairs, randomly I am selecting the centroids. This I will be taking it for K1 centroid. This I will be considering it for the K2 centroid. Done. I have a cluster. I have a cluster. For K1 what did I take? I have taken 185, 72 as one centroid. K2 I have taken it as 170, 56 as one centroid. This is one centroid, this is one centroid for the cluster. Now what I have to do? I need to use my ED, Euclidean distance formulae, to find the other things. Now I will be starting with my third row or my third data item. Now what is my third data item I have? You can see the pair here, 168, 60. Now this 168, 60, I need to check in which cluster does this coming. Is it coming for K1 cluster or is it coming for K2 cluster? To get that, I will be using my ED. Now what is the formula for ED? X minus X centroid plus Y minus Y centroid whole square under root. This is my formula for ED. Now I have third row. Now what is my K1? K1 is 185, 72. K2 is 170, 56. This is what I have, right? Now, what is my, this one, third data, 168, 60. This is my third data item. Now, to get this is my X, this is my Y. Now, this is my XC, this is my YC. This is my XC, this is my YC. Now, first I will be calculating it for K1. K1 is equal to root of X is how much? 168 minus XC is what? 185 whole square plus what is Y? 60. 60 minus 72 whole square. Now K1 is equal to, what is 168 minus 185? Seven and this is 1 minus 17 whole square plus this is minus 12 whole square root. 17 17s are 289 minus plus 144. K1 is equal to, I will be getting it as 9 plus 4 is 13, 4 333. Now it is approximately, I will consider it as something like 20.8. This is my K1 value. Next I will be calculating for K2. Now K2 is equal to again what? X. What is X value? 168 minus what is K2 this thing? 170 whole square plus what is Y? 60. 60 minus 56 whole square. Now K2 is equal to, this is minus 2 square plus 4 square which is equal to 4 plus 16. K2 is equal to root of 20 which is equal to something 4.8. Now I have got what? K1 and K2 values. Now K1 is equal to what? 20.8. K2 is equal to what? 4.8. Now, you have got to remember here, we need to check which is the lesser value. For that lesser value, would be considered for that clustering. Now K2 is less than K1. So I will be taking K2 here. Now what is the K2? This implies what? 4.8 is less than 20.8. So now the K2 is less than K1. So I will be taking what? K2. This is the rule. Whichever is less, that we are going to take as the new cluster or new cluster variable. Now, but the thing is, your K2 is already having a centroid. What is the K2 centroid value you have? 170, 56. But now what is the new one you have got? What is the value of the new one? 168, 60. So now you are going to find the new centroid. Find the new centroid for K2. So what is the formula? X plus x1 by 2 comma y plus y1 by 2 gives me the value of the new centroid. Now this is x, this is y, this is x1, this is y1. Now 168 plus 170 by 2 comma 60 plus 56 by 2. Now what is the answer? Now what is the answer? 168 plus 70 is, you will be getting it as 338 by 2 comma, this is 116 by 2. So the final answer is 169 comma 58. Now your new centroid, therefore new centroid K2 is equal to what? 169 comma 58. This is for your third. Now you all can just make a note here. You have K1, K2, two clusters. In K1 first you have 1, in K2 you have 2. Now the latest one is also there in 3 in your K2. Now next let's move on to your next row. In your fourth row, that is nothing but your fourth data item. What do you have? 179 comma 68. This is your fourth data item. Again I need to do what? Again I need to calculate K1 and K2. What is my K1 value? K1 value is 185 comma 72. My K2 value is, now the new K2 value I need to consider, that is my 169 comma 58. Done. Now again the same, K1 is root of same thing here, x, y, xc, yc, xc and yc. Now 179 minus 185 whole square plus, you have got 68 minus 72 whole square. Now K1 is equal to 179 minus 85 is 6 minus 6 square plus 72 minus 68 is minus 4 square. Your K1 is equal to 36 plus 16. 36 plus 16 is 52. So you will get K1 is equal to 7 point some value you will be getting. Next K2 is equal to 179 minus 169 whole square plus 68 minus 58 whole square under root. So K2 is equal to minus 10 square plus minus 10 square. K2 is equal to root of 200 and which is equal to 14 point something nearer value. Now here if you all can see K1 is less than K2. So what is the K1 value? K1 value is something 7 point something is less than 14 point something. So now you need to find new centroid. Therefore new centroid for K1 is, now what is the old one you have? Old one is your 185 comma 72. Now the new one is your this one 179 comma 68. Now what is the formula? X plus xc. So 185 plus 179 by 2 comma 72 plus 68 by 2. So here you will be getting it as 185 plus 179 is 364 by 2 comma 80 by 140 by 2. So you will get it as the value is 132 comma 70. This is your new. Therefore the new K1 is equal to 132 comma 70. That's it. Now again your fourth data item is moved to what? K1. So now you can see we have got a new centroid. We are going to find the new centroid because as K1 is less than K2, we are going to consider the fourth data item in your K1 cluster. Now to find the new centroid, what is the formula you have? Here you have got what? X plus x 1 by 2 comma y plus y 1 by 2. So I am using the same formula, I am calculating it. 185 plus 179 by 2, 72 plus 68. Totally I am getting it as what? 132 comma 70. This is my new K1. From next I am going to use this as my K1. Now your last fifth data item. Your fifth data item is what? Fifth data item is 182 comma 72. This is what you have. Where you know your new K1. K1 is equal to what now? 132 comma 70. And you know your K2. K2 is what? What is the value of your K2? K2 is 169 comma 58. So now again you are going to find the ED. Now this is your X, this is your Y, this is your XC, this is your YC, this is your XC, this is your YC. Now first I am going to calculate it for K1. K1 is equal to what again? 182 minus 132 whole square plus 72 minus 70 whole square. Done. Now K1 is equal to what? 50 whole square plus 2 square, which is nothing but 50 square is 2500 plus 4. So K1 is equal to 2504. So K1 is equal to your nearest value. How do you find the nearest value for this? 10 K square is 100. Let's assume something around 245 point something. I am assuming it. This is just assumption value. You calculate it by yourself. Assumption value. Next I will be calculating with K2. K2 is equal to root of what? 182 minus 169 whole square plus 72 minus 58 whole square. So now what do you K2? K2 is equal to, what is the value of K2? K2 is 169 minus this is 3, and you've got 1, 13 square plus 58. Here you have got 58 minus 72, it's 14. So now you have got it as what? 13 13s are 169 plus 196. Now what is the value? K2 is equal to root of 225. Yes? Yes. Is it 225? No, it's more than 225. This is 5. Okay, 110, 6, 365. So K2 is equal to 365 is probably 17 17s are 289. I can take it as 18 approximately. 18 approximately I can take it. 169, this is 14, right? This is 14. Yes, have taken approximately this value. This is my approximates value. These are not correct values. So please check it. This also you might get lesser value, not greater value. This would be the lesser value. So now for me K1 is less than K2. If you calculate, you will get it. K1 is less than K2. So when K1 is less than K2, what will happen? Now I need to find the new centroid. Now what is the new centroid? The old one is already I have it as 132 comma 70. The new one is 182 comma 72. So x, y, x1, y1. So when it is x, y, x1 and y1, I will be taking it as 132 plus 182 by 2. Next one 70 plus 72 by 2. So now I will get a value as 4, 8, 3 is 11, 314 by 2 comma 142 by 2. So now what is the value here? 157 comma 71. This is my new centroid value. Therefore now what do you have in K1? What do you have in K2? In K1 you have what? 1, 4, 5. In K2 what do you have? What are the data items you have? You have 2 and 3. This is your final result. Therefore the two clusters are K1 and K2. So in K1 you have 1, 4, 5 are the data items. In K2 you have 2 and 3 as the data items. It is satisfying your rules, whatever rules we have spoke already. So here K1 and K2, K1 is 1, 4, 5, K2 is 2, 3. So 1, 4, 5 are the data items which are not repeating in your K2, which is 2 and 3. So we are satisfying the rules here. So this is all about your partitioning method, which is very important question. In your next session, we will be seeing about the other things like your hierarchical method, density based, grid based, and your last topic is your outlier analysis. Thank you.